Named for the American physicist Edwin Hall, a Hall effect sensor is a non-contact sensor used to detect changes in a magnetic field. They can be used to determine proximity, speed, or displacement of a mechanical system. In this episode of Radwell's How It Works series, we're going to explore how a Hall effect sensor works. First, let's review the main components of a Hall effect sensor. Hall effect sensors are made up of a rectangular piece of semiconductor material, typically gallium arsenide, indium arsenide, or indium antimonide. The sensor is housed in a plastic casing with attached output leads. An analog output sensor module will include a regulator and high-gain amplifier. A digital output sensor will include the same components with the addition of a Schmitt trigger. Now that we've reviewed the main components of a Hall effect sensor, let's talk about how it works. First, an electric current flows through the sensor. The electrons will move in a straight line. When the sensor encounters a magnetic field, the Lorentz force will cause the electrons to deviate and bend towards one side. This difference in electrons will create a small voltage, which can be measured to determine many factors of the system. Hall effect sensors are used in a wide variety of applications, such as cell phones, GPS systems, automobiles, aerospace, medical devices, brushless motors, and many Internet of Things devices. If you like this information on Hall effect sensors, like this video and subscribe to our channel for more information on industrial products and processes. For information about Radwell, visit us on the web at radwell.com or connect with us on social media. Thanks for watching!